Today our topic is solving quadratic equations. So our learning target, how can I solve quadratic equations by graphing? Key terms, solutions to a quadratic equation. When we're graphing them, they're going to be our x-intercepts. Another name for solutions, they can be called roots or zeros as well. So they all mean the same thing, just different words to refer to them by. Example 1, find the solution to x squared minus 2x equals 3 by graphing. So first off, we want to set our equation equal to 0. We should remember this from chapter 9. Subtract 3 on both sides, we get x squared minus 2x minus 3 equals 0. Graph the equation. So taking this piece, we have the equation y equals x squared minus 2x minus 3. Identify your a, your b, and your c. A is 1. B is negative 2. C is negative 3. Find your line of symmetry. X equals negative b over 2a. B is negative 2. A is 1, so 2 times 1 would give us 2. Negative 2 divided by positive 2 gives us a negative 1, excuse me. So we have negative, negative 1, which becomes a positive 1. So we can say x equals 1. That is our line of symmetry. We can graph that. Next piece that we need is our vertex. So using x equals 1, we plug that into our equation. So we have y equals 1 squared minus 2 times 1 minus 3. 1 squared is 1, minus 2 times 1 is 2, minus 3. 1 minus 2 is negative 1 minus 3 is negative 4. So our vertex is 1, negative 4. Then we need to make a table to graph other points. So if you like making a vertical table or a horizontal table, doesn't matter. You can make it how you want. Give some blanks here. We're going to want our vertex here right in the middle, 1, negative 4. Put 2 and 3 on the right of 1 and 0 and negative 1 on the left. And let's see what we get when we put those solutions in. We put 0 into our equation. We would get y equals 0 squared minus 2 times 0 minus 3, which leaves us with y equals negative 3. So we can graph those points. Then we can put negative 1 into our function. We get y equals negative 1 squared minus 2 times negative 1 minus 3. Negative 1 squared is 1. Negative 2 times negative 1 is positive 2 minus 3. Y equals 1 plus 2 is 3 minus 3 is 0. So 0, 0. That's what we're looking for. We're looking for those x-intercepts, so the time when y equals 0. So if we look, we can graph these points. These x-intercepts right here that I'm shading in blue are the solutions. So this coordinate point would be negative 1, 0, and this coordinate point would be 3, 0. So that's our solutions. Our solutions are x equals negative 1 and x equals 3. That's what we're looking for. Next example, we're doing the same thing. We want to find the solution by graphing. So first off, we want our equation set equal to 0, minus 1 on both sides. We get negative x squared plus 2x minus 1 equals 0. We want to graph the equation. So the equation is really y equals, then this piece right here, negative x squared plus 2x minus 1. identify our A, B, and C. A is -1, B is 2, C is -1. Remember, we get that from our standard form of y equals ax squared plus bx plus c. Find your line of symmetry. X equals -b over 2a. Fill in the pieces. Negative b is 2 over 2 times a, which is -1. 2 times -1 would give us -2. 2 divided by -2 is -1. Double negative here makes a positive, so we have x equals 1. That's our line of symmetry. Find our vertex. That's what we want next. So that's the point where x equals 1, and we want to solve for y. So we use our equation. Y equals -x squared. So instead of x, we're putting 1 in for x plus 2 times x. So 2 times 1 minus 1. 1 squared is 1, so -1 plus 2 times 1 is 2 minus 1. -1 plus 2 is 1 minus 1 is 0. So our vertex is 1, 0. Right there on our x-axis. So now, if we find our y-intercept, we put 0 into our function, or we just use the fact that our y-intercept is c. It would be right here. If we graph this function, we look, the only time we're going to touch the x-axis, this line right here, is at that vertex. So this is a special case, and it only has one solution, and that's what it looks like when it's graphed. When we just have the vertex on our x-axis. So that one solution is right here at 1, 0. So our solution is x equals 1. Last example. Find the solution by graphing. Again, we want it equal to 0, so we're going to add 7 to both sides to get our equation equal to 0. Graph our equation. So we're getting a lot of good practice for graphing in this lesson. Again, we want to identify our A, our B, our C. A is 1, B is -4, C is 7. Find our line of symmetry. X equals -b over 2a. B is -4, so we put that in for B. 2 times A is 1. 2 times 1 is 2. -4 divided by 2 is -2. Double negative makes a positive. Our axis of symmetry is x equals 2, so we draw that vertical line. Next, we need our vertex, which is the point where x equals 2. Use our equation y equals x squared, so we do 2 squared minus 4 times x, so 4 times 2 plus 7. 2 squared is 4, minus 4 times 2 is 8, plus 7. 4 minus 8 is -4, plus 7 is 3. So our vertex is 2, 3. Plot that point on our line of symmetry. Now we can get our y-intercept for another point using the fact that our y-intercept is 0, C. So our y-intercept would be 0, 7. Plot that point on our graph would be right here. Use the symmetry to plot a second point and connect your points. We have 3 nice points on our graph. We can make a nice U shape. Now if we look here, this is another special case. This is one that never touches the x-axis, which means it has no solution. If it never touches the x-axis, you can't have any solutions to that equation. That is all the notes that I have for you. Reminder for you, take your 10.3 notes quiz for practice. Make sure you come to class prepared, ready to go.